This is GCSE Physics. This is the particle model of matter. This is lesson number 9. And the title is Doing Work on a Gas and Exam Style Questions. So the objectives are to primarily explain why a tyre gets warm when it's pumped up. That's a specific example that the exam boards want to know about or would ask you about. Secondly, give complex explanations as to how gases behave when pressure, volume or temperature are altered. So let's start with this one. Internal energy recap. So you should know this already if you've done the other lessons. The internal energy is the total kinetic energy and potential energy of all the particles within a system. So we can write an equation. Internal energy is equal to kinetic energy plus potential energy. And what is internal energy measured in? Well, it's energy, so it's measured in joules. So there's something for us to look at. So these tyres were correct yesterday at 2.7 bar. What do you think could cause all 4 tyres to slightly drop in pressure all at once? If you want to have a think about that, you can pause. So what could cause all 4 tyres to drop at once? Well, the tyres are most likely dropped in temperature. And a drop in temperature will drop the kinetic energy of the gas particles. So if they've got less kinetic energy, they're going to have less speed, therefore less force, and coincidentally less pressure. So it's quite a meaty explanation. There's quite a lot to it. Remember to make any notes if you need to. Let's move on. So why do tyres get warm when you fill them up? So if you transfer energy by applying a force when you do work, so doing work on a gas, which is the pumping action, will increase its internal energy, which will increase the temperature. So in the bi-pump example, the gas inside the tyre exerts a force on the handle that must be overcome. So work must be done to overcome that force. And the work done transfers into the kinetic energy stores of the gas particles, which will increase the temperature. Therefore, the pump will get warmer. Now, if you've ever pumped a tyre up, after you've pumped it up, you'll notice that as you're pumping it, it starts to get more difficult at the end. You have to do more work to get the air in. So if you disconnect it once it's pumped up, and then if you feel the end or the section where you plug it on, you'll notice that they've got pretty warm, and that's why. So if you need to make any notes, please pause. Let's move on. So those are these 5 questions. The explanation ones, remember, you need a full explanation, so there's quite a few points to them. Okay, if you're ready to move on, let's look at the answers. So first one, describe the motion of particles within a gas, completely randomized, which means they move in random directions and at random speeds. By random in a gas, most of the particles will be a similar speed. Some of them will go much faster and some will go much slower, but it's less. Most will straddle the average, but still randomized on any single particle. So explain how a gas exerts a pressure on the container in which it is housed. So it's an explanation question. So the particles housed inside collide with the container walls, and when they collide with container walls, they transfer momentum and generate forces on the container walls. And of course, pressure is just force divided by area. If you've not talked about momentum and jumped straight to forces, that should be okay. So next one, for a fixed mass of gas at constant temperature, what is the mathematical relationship between pressure and volume? So if you've done the previous lessons, you should know that pressure is inversely proportional to volume at a constant temperature. So when this question comes up, most separate scientists can handle the fact that pressure is inversely proportional to volume. The part that they forget is at constant temperature, so please be mindful of that. Number 4, explain why increasing the temperature of a fixed amount of gas will increase the pressure. Well, when you increase the temperature of a gas, you're going to increase the internal energy via the kinetic energy stores. So if you've got higher kinetic energy, that's more movement energy, that means you're going to get higher speeds. If you've got higher speeds, you're going to result in larger forces, and therefore higher pressures being exerted. If you got anywhere near that, well done, by the way. Next one. If volume is increased at constant temperature, explain what happens to the pressure. Well, the pressure will decrease as the particles are more spread out, and the speed won't change due to constant temperature. Therefore, we'll end up with less collisions. Therefore, you get less force, which results in less pressure. If you need to make any notes on that, please pause and do so. Let's move on to an exam style question. So this question's worth, it's very similar to an exam question. It was worth 5 marks. So if you want to have a pause and have a go at this one, I believe it's relatively straightforward. Okay, let's look at the answers. So number 1, describe the motion of the particles in the balloon. It's just a description. We'll have a range of speeds in random directions. Second one, what is the name given to the total kinetic and potential energy stores? That's obviously the internal energy. And thirdly, a calculation question which we're going to look at. So density, this was lesson 2 in the particle model series. Density is mass over volume. So the mass is 0.00312 kilograms divided by volume of 0.0162 meters cubed. Put that in your calculator and that'll give you the density. And the density is 0.19 kilograms per cubic meter. The unit, obviously the mass is in kilograms, that's in meters cubed, so kilograms per meter cubed. Hope that went okay. The next question is a little bit challenging, I think. Let's have a look at it. So if you fancy a challenge and want to answer this without any tips, I want you to pause the video now. And then I'm going to show you a tip. And it says, show using figure 1 that pressure is inversely proportional to volume. What you need to remember from the previous lesson is that pressure times volume is equal to a constant. So that's the tip. And then I'm going to go for the answer. So if PV equals a constant, that means if we check a couple of locations on this graph and we multiply the pressure and the volume, we should get the same constant, same number. And if we do, that means that pressure is indeed inversely proportional to the volume. So the 2 points we can pick that are relatively straightforward to see from the graph are this one and this one. Okay, so the first one is 200 kilopascals. So we've got 200 kilopascals. So you just do 200 multiplied by the volume, which is 8 centimeters cubed. So 200 times 8. So for this point A, 200 times 8 gives us a constant of 1,600. Just out of interest, what do you think the units are for pressure times volume? Well, pressure is pascals, but pressure is force over area. So that would be newtons per meter square. Newtons per meter square multiplied by volume, which is meters cubed. So the units, they'd cancel. You'd actually end up with Newton meters. Just out of interest, it's not really terribly important. Let's pick point B. So point B would be, so we've got a pressure of 160 multiplied by 10, which is 1,600. So the constants are the same. If you converted if you did 200 times 10 to the 200 kilopascals, which is 200,000, and 160,000, that's fine. But constants are the same. Therefore, pressure is inversely proportional to volume. Hope you enjoyed that. In fact, let's enjoy it a little bit more. And I hope you found it helpful. Thanks for watching this series of lessons, and I'll see you at the next one.